Hi, my name is Alejandro, an engineer at NI. I'm here today to demonstrate how you can use PXI Vector Signal Transceivers, or VST, to perform fast and accurate EVM measurements. In our system here today, we have the PXI 5842. We are generating a Wi-Fi 7 signal and sending that out of the signal generator of our VST to our power amplifier device under test. We are then acquiring the output from the power amplifier back in our VST. We also have a PXI source measure unit to provide power to the DUT. On the software side, we're using the RFmx soft front panels in Instrument Studio to generate our signal and acquire our results. This particular signal is a Wi-Fi 7 802.11be waveform. It has a center frequency of 6.5 gigahertz and a bandwidth of 320 megahertz. Moving to the signal analyzer front panel, we can see our spectral emissions mask, as well as our OFDM modulation accuracy measurements, including the constellation diagram and EVM per subcarrier. Now, in many situations, it's useful to sweep EVM measurements over various different power levels or frequencies in order to obtain a more thorough characterization of your device. For that, we can use the RFIC Test soft front panel. We are using the same waveform that we had used in the RFmx soft front panel in Instrument Studio. Once we configure our waveform, we can set our power sweep using the DUT tab in our front panel. All we have to do in order to do this is enable sweeping. In our power sweep option, we'll set our start power at -40 dBm, our stop power at -15 dBm, and we'll set the interval at which we want to take measurements. In this setup, we'll use a 1 dBm measurement intervals. We can then apply DUT power using the button at the bottom of the screen and hit run. Now we see the same results that we saw in the RFmx soft front panel, only this time it is sweeping through various different power levels, and we can see that with each iteration of the measurement. We can see once again our spectral emissions mask, linearity measurements, and our modulation accuracy on our EVM versus subcarrier here. Of course, we can also see our EVM sweep giving a bathtub plot of this particular power amplifier. Finally, on the bottom right is a summary of all of our measurement results. Using this configuration is very quick and easy to set up EVM measurements and visualize the results. For more information on EVM measurements using PXI Vector Signal Transceivers, visit ni.com/semiconductor.